Lambda on OpenStack is a compute platform that allows users to execute their functions without getting into resource provisioning or execution. So this reduces their operation cost, and developers can focus only on their code and not into resource provisioning and management. This provides the users to upload their function, register them with an event, and get it executed when the event comes in. This also provides a dynamic resource provisioning, wherein the service gets upscaled and downscaled based on the load that comes into the cluster. This is the whole workflow of Lambda service, wherein you can see there are two interfaces, one on the top left where it receives the event, and one on the bottom left where a user can upload its function using a REST API. So initially, user uploads its function using a REST API that gets stored to a MongoDB. Whenever an event comes in via RabbitMQ engine, the event listener picks up the message, passes on to the orchestrator. Orchestrator dips into the DB, find out the corresponding mapping, the function parameters, and the function, and passes out on to the provisioning component. Now, provisioning component interacts with the Docker swarm and creates a container over one of the child VMs and get the code executed there. In this whole workflow, there is a monitoring daemon running that keeps a track of the current cluster health and cluster resource utilization, and based on the resource utilization and the load factor, it creates a new VM, or it kills a VM and maintains the resources and the resources available as per the load. So during this whole execution, we monitored some performance figures. So the VMs that get created are generally 2 CPU and a 4 GB RAM. Initially, a VM provisioning takes something around 60 to 90 seconds, depending on the network availability, the VM provisioning time, the time taken by it to be ready with the key mapping. Once a VM is up, the container provisioning takes less than a second, because the container image that we're using is already pre-configured with all the installations. VM downscaling takes hardly 15 to 20 seconds, because it's just the deletion of the VM that takes place. Post deletion, the cluster heartbeat gets updated every 30 seconds, and it's the 30-second duration after the deletion that leads to a downscaling of the cluster. 80 to 100 functions get executed at any point in time when the cluster gets overloaded, and for every one request per second, it take for a running period of 10 minutes. We had almost 60 containers created on two VMs of size 4 GB and a 2V CPU. Now this service has a few limitations as well. Like, as of now, it supports just a single execution environment, that is Python. It provides just a one-way async request execution. There is no option for a request response as of now. It has not been tested on very high load environments, and we had like limited resources and limited number of VMs. It has a limited execution time. The code execution time is 1 minute. If the code doesn't get executed in that specific time, that particular request is discarded. And another limitation is like user does not have access to that specific execution environment, or he or she could configure that specific environment. Whatever is the predefined environment, the user has to execute its function on that specific environment itself. Now this was our journey so far. So we started with implementing RabbitMQ and initial instance creation and deletion on MOC. Then we created a UI and the APIs using Ruby and Sonata server. We introduced Docker, and we implemented all the components in Python. Later on, we implemented MongoDB as our data store. We came up with Docker Swarm when we wanted to have multiple containers, multiple VMs running at a time. and we came up with a happy flow. Later on, we enabled function logging and automated the creation of VM and uh, container creation. Post that, we came up with a concept of deprovisioning of the VMs and the container creation based on the parameter that has been defined by the user, like the memory size of a container could have multiple memory sizes, and based on that the container will get created and the function will get executed. So what were the learnings on this? We came across a lot of frameworks and technologies like Sinatra, Docker, Docker Swarm, Console, and OpenStack. We use multiple languages like Ruby to create our web UI, RabbitMQ to as an interface, and the whole service was written in Python. The execution environment was provided by Docker over OpenStack cloud. We also learned how to manage and to deal with dynamic provisioning of the resources. There are also some learning about the open source softwares, how to use them, how to interact with those, and how to figure out if there are any limitations to that specific technology or specific software. Apart from that, our major learning was working into an agile model, managing resources and creating tasks which are very fine grained, and to work on it and to estimate the time, the execution time as well. For the future enhancements, we are looking forward to extend it to handle multiple execution environments, make it more scalable, and bring down the initial provisioning time and the execution time, increase its robustness, and have a good failover. And apart from that, we are looking forward to pitch our idea to the OpenStack community and as an open source solution. So now it's time for the demo.
Hello everyone, this is the sixth demo for Lambda on OpenStack project. As explained earlier, Lambda on OpenStack is a compute service which allows a user to upload a code in the cloud environment and get it executed based upon an event and its details from a queuing service. Today we are going to see a full lifecycle development, lifecycle execution of an event, of a function based upon an event. Before we go into further details, let me give you an overview of a rather important point that we faced about in the last sprint in sprint 5. As explained in the previous demos in the previous sprints, we were using Docker Swarm and Docker Hub and Docker Swarm as our discovery and registry services for containers and VMs. One of the problems with Docker Hub was whenever a new machine is created or destroyed, the Docker information that we fetch from command line was not getting updated as fast as we were expecting it. So because of this tail information, the cluster information was not getting updated and we were not able to create and execute the functions as fast as we would have liked to do. So we decided to move, based upon the community reviews, we decided to move from Docker Hub to using the console discovery services. In this demo, we are using the console discovery service, which has given a rather significant improvement in our execution time of any function based upon the event. Let me go into the setup of this demo. This window over here shows the event listener, which is a queuing service which listens to the event running in the queuing service. This window over here is going to get the information about the cluster containing a set of VMs and the containers. Here we're going to run the file create service, which is a demo test service which allows the user to create a file service, which allows the user to create a file and send the event to the queuing service. As talked earlier, this is I'm going to show you the console and the Docker master service that acts as a manager to federate the new VMs created. The way the console works is, and the whole environment works is, we create a master machine which acts as a server, and hosts all the installations about Lambda service, the queue, and the command line interface as well. It also acts as a discovery service for the console. Whenever we need to create and add or join one of the new VMs to this manager, we have to log in into that machine and run the Docker Swarm join from that machine using this manager IP. For this setup, for this demo application setup, we have already created a manager as well as joined a initial Docker VM. So here you can see by running this command on this IP, this says that Docker is running from this port, and we can get the information from PS. We can see the master machine, the Swarm manager running and with this container ID, as well as the console container running with this ID. Coming to the event listener, we can run the event listener from Python queue event listener, queue event receiver. So here you can see that it needs my OS username and passwords, which I can set it right now. Yeah, now my queue receiver is running up and running. Here in the event service, I'm going to run the file create service.rb, which acts as a test service which creates a file and pushes the event to the queuing service. Now I'm running it in an infinite loop with a sleep of 2 seconds, which will act as a which will create a load on my Lambda service and keep on firing the events. Now, as soon as my Lambda service starts, this queue receiver has started listening to events and trying to run the code. This tester py is the function that the user has uploaded. You can also see that function in the database. Based upon the user threads, these many functions have already been uploaded by the user. You can see this file name test.py uploaded by the user test user. Now let's go and see our Docker information. Now currently my Docker information gives me the information about the VM and the container that is currently running in my environment. Right now I have only one node and 6 containers running on that node. The utilization on this machine is 1.25 GB versus with the availability of 4.054 GB. To get a continuous information about, I can run this in the while loop to get the whole information continuously. Yes, so currently it is showing me all the information about the nodes and the new machines. If you see this in this window, the functions are getting executed based upon the events. So these are the execution logs. So let's go and scroll and see one of those logs and see what's happening there. It received one event and it is trying to provision a machine and create a Docker machine and get the code executed there. You can see over here that the utilization of the memory as well as the number of containers keeps on fluctuating between based upon the request that is coming up. Now there is a background health check that keeps on running based upon which the new machines get created and are destroyed. As explained previously in the previous demos as well, if the utilization is above 70%, then we create a new machine and federate it or join it um, with the SOM manager. As well as if the utilization is less than 20%, then we destroy the machine and then we destroy the machine and bring it back into the and leave it to the resources available. You can see that the container size is continuously increasing based upon the load right now, and the reserve memory utilization has gone up to 3 GB. As per in this queue receiver, as soon as the queue receiver receives an event, it it starts a new thread to execute this event, to execute the function corresponding to the event. So the requests go into the queue, and if there is a resource available or a container available to execute this process, it executes it, otherwise it remains in the queue. So if I stop the sender events from the event services, this queue service will the listener will keep on going until unless it exhausts all the processes and all the events and it executes it. You can also see in the Kaizen portal if there are any new VMs created. So this is the child VM, which is the newly created VM, which gets federated with the Docker managers. We keep the size of the new VMs created as the medium machine with 4 GB of memory space, and the amount and the containers that are getting created on the VMs depend upon the input provided by the user. That is all I had for the demo for Sprint 6. Please let me know if you have any questions.